principles of thermodynamics, all objects tend to acquire the temperature of the environment where they are placed. When the object has a higher temperature, it rejects heat until it reaches the temperature of the environment, meaning it cools down. Similarly, when the object has a lower temperature, it absorbs heat, meaning it heats up. The operation of the air conditioning systems is based on this principle. Hot air, 28 degrees Celsius, in a closed space, cools down, coming in contact with an object of lower temperature, water, 7 degrees. The chilled air produced diffuses at 16 degrees to the closed space, keeping it an agreeable temperature, while the water temperature heats up and reaches 12 degrees. For the water temperature to go down again to 7 degrees in order to keep on cooling, it consumes electricity. This electricity is consumed by the chiller, which helps to reject the absorbed heat or cooling load to the atmosphere. To keep these conditions steady, we need to constantly provide the cooled closed space with 16 degrees temperature air, which requires the constant consumption of electricity. In effect, that means that in order to cool space, we have to pump heat from a lower temperature level, cooled space, and reject it to a higher temperature level, environment, a process that requires energy consumption. The greater the temperature differences between space and the environment, the larger the energy consumption. So if the cooling system rejects heat to the atmosphere during summer, when the temperature reaches 45 degrees, the difference becomes greater, and so does the electricity consumption. On the other hand, if the heat is rejected to the sea that has a lower temperature than the atmospheric air, then the temperature difference is reduced, and so does the electricity consumption. Actually, heat pumping is done in more than one level. From the confined space to the air conditioning system, then to the cooling tower, and from there to the atmosphere. Seawater cooling is an innovative technology developed by Heliostat Ltd to support cities of tomorrow air conditioning with increased efficiency. The relevant demonstration project is implemented for the first time worldwide in the island of Hydra. The municipal system consists of an underground pipe network that circulates soft water. Through plate heat exchangers, the cold seawater and the water used by the city's system come in contact. In this application, the cooling load is pumped in 4 stages. First, the chiller with the help of cold water pumps heat. Second, using the central municipal system, the heat is conveyed to the central coolers. The system's water returns cold to the air conditioning systems through the underground pipe network to continue pumping up heat, while seawater returns back to the sea at a higher temperature. The central municipal coolers consist of one or more plate heat exchangers that provide the necessary heat transfer surface. The seawater is pumped using submersible or surface sea pumps, and before it reaches the plate heat exchangers, goes through the necessary automatic cleaning filters. Finally, the seawater carries the rejected heat back to the sea, where with the help of undersea currents and sea breeze, it is naturally dissipated to the atmosphere through the evaporation process. The final stage transfers the cooling load to the atmosphere naturally, without consuming any primary energy and without increasing the atmospheric temperature.